Hey everybody, and welcome to the video. Pat Flannery here, and I've got Daniel Gyorev with me from Sorama. He's coming to us from the Netherlands, awesomely. And Daniel and I met at the Building Knowledge Conference here in Ontario. He was over here showing off what I thought was a cool new technology. It was something oh, there it is. Look at that. Hey, he's got one with him. It's yeah. This is something I had never seen before. Basically, the idea is it's an acoustic camera that uses sound to check for air leaks, and I'm not even going to attempt to explain it all. But Daniel, great to have you. Great to have you with us.
Likewise, yes, I would love to explain how technology works. Let me go ahead and share my screen.
All right.
There we go.
Daniel's
Okay,
going to run
just
with this
gonna,
presentation, and I'm going to drop out, and we'll talk a little bit at the end. So you,
yes.
you,
See,
you tell the people what they're missing, Daniel.
yeah, thank you. See you in a bit. Yeah, today I'd like to explain a bit about acoustic camera technology. In a nutshell, it's a device that visualizes sound, similar to what thermal cameras do, but instead of heat, we show sound differences. How it works is that the camera uses many microphones to listen to sounds coming from all directions. We have 64 microphones. You can think of it like 64 ears listening to sounds. What happens is when you have a sound wave coming from a specific direction, the microphones pick it up and visualize it in the form of a heat map on the screen. In buildings, how it works is that you use a speaker that generates a specific signal. It can be some signal that people can hear or people cannot hear if it's a very high frequency signal. Then those sound waves, they travel outside through any opening like a gap or crack or fracture in the building. And on the other side, with an acoustic camera, you pick up those sound waves and visualize them. Because physically sound travels through air particles, you know for a fact that every sound leakage you're able to visualize corresponds to an air leakage as well. It also shows a direct fracture in the building, so it can also be used for water leakage applications as well. Here, I'm showing you a video of three speakers playing at the same time next to each other. On the right side, you see the frequency spectrum that's also visible on an acoustic camera. And what you'll notice is when you change the frequencies, the different speaker gets highlighted. That's because the speakers generate a different frequency and you can actually play with that. For example, if you are doing a measurement of a building in a very noisy environment, you might, for example, see that most of the frequencies, for example, of cars passing by are up to, let's say, 10,000 hertz. So that also gives you some information what kind of signal you want to be generating to optimize your measurements. And we use that in factories, actually. I want to show you here an example. This is a compressor. You see that there are different sound sources, and as you shift the frequency spectrum, different source gets highlighted. One of the most common applications of acoustic cameras is to visualize gas leakages or compressed air leakages of high pressure systems. What happens is when you have a small crack in a pipe when compressed air travels through it, it creates very high frequencies that people cannot hear, but you can pick them up with such technology. So you can actually, because it's a different frequency, you can visualize very silent leaks in a still very loud environment just because of the frequency difference. Here, I want to show you on site to do tests of a building, how it works. So you have a sound source and an acoustic camera. Here is a video testing a door. You'll see on the other side, I have just a simple Bluetooth speaker that generates white noise. Those are frequencies that people can hear, and you see where the camera shows you the main leakages and gives you information where possible air leakages and water leakages might be occurring. You can use different types of speakers. Some are more powerful and some are less powerful. We prefer to use what we call an omnidirectional speaker. It's a special sound source that generates sound 360-degree angle. That way, you're sure that when you generate your sounds, every little corner or gap has been pressurized with sound. And if the sound is able to escape, you'll be able to pick it up on the other side. However, if you have just a simple Bluetooth speaker, that doesn't mean you cannot use it. So you can just, for example, if you're testing a window, you can just hold it in your hand, move it around the window frame, making sure that the sound reaches everywhere. And on the other side, see with an acoustic camera where the main leakages are. Currently, how it works, when we do air leakage test of a building, as you know, we use a blower door fan that pressurizes the building. And then to start investigating where the leakages are, we use an infrared camera, which relies on temperature differences, and a smoke generator, which relies on visual information to show you the leakages. I want to tell you how acoustic imaging can fit into that mix. For example, you can use an acoustic camera before a blower door test to preemptively find where possible leakages might be, seal them, and ensure the air leakage test goes as smooth as possible. In the summer months, when the temperature difference is not enough for a thermal camera to work, of course, you can use an acoustic camera as well. Here, I want to show you how an acoustic camera compares to a thermal camera. On one hand, the major benefit is that you are not dependent on installing the whole blower door setup to actually find leakages. All you need to do is just turn on a speaker, and within a few minutes, you can start investigating. Another big advantage is that with an acoustic camera, you can test buildings that are not fully enclosed. So during the construction process, as you build, you can test if there are any openings, gaps or cracks that I need to seal and ensure that the building is as airtight and as watertight as possible. Here is a side-by-side comparison. This is a newly built passive house project undergoing the blower door test. On the left side, you can see how a leakage will be registered through the thermal camera, and on the right side, how we see it with an acoustic camera. We can see the same leakages, and even in some situations, we can see more with an acoustic camera. For example, here, if you look closely, you can see that the thermal camera shows the main leakage mainly on the bottom right corner of this window frame, whereas the acoustic camera shows the leakage, the whole bottom part of the window is leaking. So you can use an acoustic to double check if the thermal camera leakages you're registering are real leakages and not maybe false positives or some other disturbances. Yeah, to summarize, the main advantages is that it's much quicker, much faster. It's quite easy to set up. You can test buildings that are not fully enclosed. And in some situations, an acoustic camera can be more precise than a thermal camera. When it comes to the distance, you can see sound sources from pretty far. For example, if I point at the helicopter in the sky with an acoustic camera, I can see the sound source from hundreds of meters away. It's important to note that the distance and resolution, it's always a trade-off. Even if you can see a sound source from 50 or 100 meters, to actually pinpoint the exact location of the leak, you'd have to come closer. The optimal distance, I would say, is somewhere between 2 and 4 meters away from the element that you're testing. Probably you're wondering what happens when I want to test high-rise buildings. There are multiple ways how you can do that. For example, if you already own a drone, you can just simply fly the drone on the outside of the building, and the drone noise is white noise. The propellers make white noise, and that's actually the most common signal we use to test buildings. So just simply flying the drone on the other side is already a sound source in itself. And if you are on the inside of the building, you can just simply scan the window frame for any leakages.
Huh.
The visuals are pretty clear, and you can integrate them with your digital drawings to, for example, select a specific room of a building and check where the main leakages are. I already touched a bit upon that. The applications of new construction, which is currently, of course, not possible to do a blower door test before the building is fully finished and everything is sealed. But this is a great advantage because you can, while the builders are still there, you can use this technology to quickly show any openings that they might have missed and seal them on site, and not having them return again on site after it's finished, which is also, of course, extra time and extra cost and extra hassle for everyone. Here I'm showing you an example of an acoustic boot and how this manufacturer is using an acoustic camera to test for leakages of this small enclosure. If you deal with any prefabricated building element or modular units, you can use this technology during the manufacturing process to ensure that everything is produced of the highest quality possible. Then once this prefab element gets installed on site, you can use again an acoustic camera to check where possible sealants might have been missed or if everything is still intact. I know that it's a big issue for many prefab manufacturers that during transportation of the elements, some seals get broken. And when you install it on site, it's not of perfect quality. Of course, if you are installing high-performance windows and doors, you know how important it is to make sure that they are installed as good as possible. Acoustic imaging is a great way to ensure there are no openings, no gaps and cracks around the window frame that allow air and water to enter. Even if you have the best performing window, but you install it in a bad way, it's not great. And here you can see a few, of course. Many times, structural issues will be visible with your eyes. And if you have an air leak, you might be able to feel it with your hand. But when we talk, for example, about passive houses or very high-performing buildings, you want to ensure that even the tiniest gaps that you cannot see with your eyes are sealed correctly. And an acoustic camera can be a great tool for that. Here are a few examples of how you can test facades. As mentioned, you can find sound sources from 50 or 100 meters. So even if you are on the first floor of a building and you want to test the second or third floor of that building, that will be perfectly possible. If you are testing, for example, skylights or roofs for water leakages or just ensuring the correct installation of your skylight elements, an acoustic camera, after you install it, can show you some gaps that might have been missed and that should still be sealed. On the right side, you can see this is actually a project we did with a roof manufacturer. They hired us for an investigation because their client complains that after receiving the new roof system, which was supposedly better, they were actually more bothered by leaks, both air leaks and sound leaks, and they wanted to investigate where they're occurring. We could find the leakages both by placing the speaker on the outside of the house, and we could see where the sound was entering. And by placing the speaker on the inside of the house, we could see where the sound was escaping. If you're testing sealants, whether they need to be replaced or not, that's also a great application. Right now, I'm not aware of any method that allows you to test sealants in a non-invasive way, apart from having an expert look at it and say it's okay or not. But then, yeah, it's not the most scientific method, and secondly, it can be argued whether that expert is just their opinion because they want that sealant replaced, or whether it actually needs to be replaced. But when you can show it to a customer that, hey, look, you can see the leak with your own eyes, that makes them believe it much more. If you're testing walls, for example, let's say for apartment buildings, it can be an issue having a secondhand smoke infiltration. And if you want to diagnose what the issue is, if the connection between the interior wall and the ceiling is not perfectly sealed, which allows, of course, air to travel from one unit to the other, you will be able to visualize those with an acoustic camera as well. Here, I want to show you some of the results we did on a newly built passive house project and some of the leakages we were able to identify. Here you can see some of the leakages around the door frames and window frames. With all the leakages we were able to identify, of course, the building did not pass the blower door test, so they had to add extra sealants to ensure that it was more airtight. In offices, these technologies are used mainly for sound leakage applications. For example, if you're talking about highly sensitive buildings, for example, we did a project with the Unemployment Bureau of the Netherlands. They were very concerned about sound leakages because people go there to discuss very sensitive information. And you don't want to be sitting in a meeting room and people on the other side are able to hear your conversation. So they wanted to ensure that everything is as soundproof as possible. Same holds true for hospitals and medical institutions, where, of course, sensitive, and governments as well, where sensitive things are discussed. Here you can see some of the enclosures in the meeting rooms and the sound leakages we were able to identify and later on fix. The technology is also being used for clean room inspection. Of course, these are they have to be very clean environments. So when you are doing, for example, a blower door test, you are not allowed to use smoke because you'll contaminate the environment. And if thermal camera is not an option, an acoustic can be a very elegant solution for that. Here are some of the other results as well. This summarizes the applications in the building sector, but acoustic cameras have a wide variety of applications. Here you're looking at how it is being used in industries to search and quantify compressed air leaks. So you can just simply point an acoustic camera to the leak that you have identified, make a measurement, and the camera will give you a report showing how many liters per minute you're losing with that leak and how much it costs you per year. In many situations, you can see that companies who invest in this technology, they are able to earn back the investment within 2 or 3 months because of all the leaks they are able to identify and later on fix. Another application is to test high voltage systems, especially when you have insulation issues around high voltage systems, and that also creates high frequency sounds that people cannot hear. Sometimes you can, for example, if you have noticed when you pass by an electrical system and you hear this buzzing sound, that can also be an indication of a failure. And this actually summarizes what I wanted to share with you today. Here I want to show you physically how one device looks like. So here in the front, you have the microphone array with 64 microphones. And on the other side, you have a display showing you the color map and all the information as a user.
That is super cool, Daniel. I like that. So it sounds like you're suggesting this technology is better than walking or just walking around with your cigarette and holding it near the window to see where the is that is that because that's the old way to do it.
Yep. Well, Netherlands is becoming a smoke-free
Right,
country.
right.
So
Well,
yeah.
listen, that was one for the very old timers, okay? That was
Yeah.
a long time. Yeah, exactly. Hey, it also strikes me this would be great for spying on a house, right? Because if someone is talking inside the house, you could stand out on the street and beam the thing at it and see if there's any sound coming out, right?
Yeah, could be. We have never used it for that, but I guess that's an application. All kinds of strange applications come our way. For example, we have someone using it for ghost hunting.
Oh,
They use they
yes,
use a
yes.
device and go to there in Ireland. They go to castles and haunted places to search for ghosts. Whether they find any, I don't know. But yeah.
That's awesome. Um, the one thing I was thinking a lot watching that was does ambient noise ever cause a problem at all? Like if you've got trains or city streets or stuff like that, would that ever be an issue?
It can be, but there are ways how you can mitigate that. I explained it in the presentation that the color map you see is based on the frequency you select as a user. For
Ah,
example, if you a car's passing by, that will be up to a certain frequency. And if you generate your signal outside of that frequency, then there will be no disturbance.
okay, it won't be looking for that. Um, does the like different materials will conduct sound differently, obviously, right? So you've got the glass on the window, you've got the and then the frame could be aluminum, it could be vinyl, it could be fiberglass, it could be all these different things, right? Um,
Yeah.
does that doesn't bother it? You don't have sound coming through at different rates on different parts of the facade and
Um,
creating an issue?
Yes, so you're fully correct. It doesn't bother it because the sound visualization technique we use is based on the sound vibrations that travel through air particles. And the examples you're mentioning, you're talking about structural vibrations, which is also sound. And you can visualize that, but we're using a different method that doesn't interfere with the structural vibrations.
Yeah, basically it's not listening to those frequencies. So it's only the air. It's only something that comes through in the air that it cares about.
Yes.
Yeah, okay,
Yeah,
great.
indeed.
Hey, listen, it's very interesting. I think it's something a lot of people are going to be more in because as you pointed out in the presentation, you know, with the energy efficiency push and the rules getting tighter and tighter. I know you guys are will be way ahead of us in the Netherlands, but over here we're getting there. There's certainly air tightness has been a big thing here for 15 years.
Yeah.
But like you say, with the passive house and getting making the envelopes tighter and tighter, and then some jurisdictions at certain energy tiers are now asking for uh, like retesting. They want the energy advisor to come in after the building is built and actually check all that again. They're not just ticking the box and saying, "Oh, you put the energy efficient stuff in, we're done." They actually want it tested for whole house approaches, and so this is something that people are probably going to be looking at more and more, right?
Yeah, definitely. So here in Europe, we do see this need for more energy efficient buildings. I know in the next few years, the governments are requiring that, firstly, all government buildings are net zero. And in a few years, all other buildings will have to be built net zero. So building owners will have to do something about the air leakage and energy efficiency of their buildings,
Yeah.
as well in Canada and in the US.
It's happening. Yeah, it's coming. It's well, the plan is there. They're talking about I think they moved it 2 years. I think it's 2032 or something. They're talking about all the new builds will have to be net zero in Canada, and not just government, but also new houses. So yeah, this
Yeah.
is and there are performance paths to that, like building net zero houses by assembling together various conforming products is actually can be a difficult way to do it, especially if you're trying to do it the house less expensively. So
Yeah.
so when people start moving and builders start moving to performance path and are looking at the whole energy use of the whole building, that's when they're really going to need something like this, because they're going to have to be able to confirm that they're not leaking energy and sound out.
Yeah.
I really like the point about being able to check for sound leakage as well as air leakage, because that's another thing we're seeing more and more of is cities are asking for higher and higher levels of sound abatement through the fenestration and through the windows, and you can basically check that on yours, right?
Yes, yeah. It's unfortunate that for many construction companies, sound and acoustics is not really important aspect. But we do get a lot of complaints about poor acoustics. Even in many cases, people are so bothered by noise pollution that they're ready to sell their property and move elsewhere. That's a big issue.
Yeah, it's something that well, you'll probably get more complaints about that than you will about the building not being energy efficient enough.
Yeah.
You'll get a complaint about the sound a lot faster than than the other thing. That's for sure. Yeah, and so you can just now, does your can your device be set to generate an STC, a sound transmission um, um, quality?
Yeah, for sure.
Okay.
Yeah, so we've made it actually quite simple in a way that you don't need to be an expert to do it yourself.
Yeah.
So we on the camera will guide you. It will give you a step-by-step process what you need to do the STC test, and in the end give you the official report whether you pass it or not.
Sorry, I should have shut my notifications off. I think I gave you a ding in the middle of your presentation there, but that's
No
life
worries.
of that's life of the fast lane. Listen, Daniel Gyorev, the company is called Sorama. Uh, Daniel, where first of all, you are serving Canada, right? Or you're just coming to
Yes.
Canada a lot? Is that
So we are based in the Netherlands, but we do have an office in the US, and we do service North America. We're all over the world.
okay? And if people want to have more questions, they reach out to you.
Yeah.
Okay, great. So we're going to put your contact information and Sorama in the show notes, and so by all means, if you have more questions for Daniel about this technology, ask about it. I find it fascinating. I haven't seen. It doesn't mean it doesn't exist, but I haven't seen anyone else doing anything like this over here. So I would like to, yeah, I'd like to thank you, Daniel, for coming on and telling us all about your acoustic camera technology.
Yeah, thanks, Patrick, and thanks for this opportunity. Of course, it was a pleasure for me.